Join me in this video tutorial series as I teach you how to write a stunning 3D space shooter in Unity. We're going to start out by creating a blank Unity 3D project. We're going to import some assets from the Unity Assets Store. We're going to lay out our background, complete with customizable skyboxes. And finally, we're going to create a game object prefab for the player ship. And we're going to add customizable input controls. And we're going to fly it around in our 3D space environment. All that coming up in this very first episode of what should promise to be a very informative Unity tutorial series. In order to develop a game in Unity, you need to install the Unity game engine. Go to unity.com/download, and I'll provide this link in the description. And you can create a Unity ID, log in, and you can download the UnityHub for Windows. After you install the UnityHub, you're going to want to install a version of the Unity game engine. You can have several different versions of the engine if you want. For the purpose of this tutorial, I'll be using 2022.1.2F1. Okay, so now that you've got UnityHub and Unity installed, we're going ahead and create our project. So in UnityHub, you click New Project, and I'm going to select version 2022.1.2F1 of Unity. If you're following along, you might want to go ahead and use this version because it's possible, I'm not certain, but it's possible I'll use some of the new C# features that were added in 2022. So maybe just in case, it'd be good to use the same version. So I've selected 3D Core as the template that we're going to use because this is going to be a 3D project. And I'm going to use the standard render pipeline. So we'll give our project a name down here. I'm going to call it 3D Space Shooter Tutorial. And I'm putting it on my external SSD drive under a folder called Dev Unity Projects. You can put it wherever you want. Click Create Project and let Unity do its thing. Now this is going to take a little while. So I'm going to stop the recording and I will resume it after it's finished doing all this preparatory work to create the project. Okay, so Unity has finished creating the project, and this is what it looks like when it first opens up in the Unity editor. So you'll see we've got a sample scene here that just has a main camera and a light source. What I'm going to do is a little bit of setup that I find helps me to organize my projects and makes them easier to maintain, especially as they grow in size. So first of all, excuse me, under the Assets folder, I am going to create a new folder. So I right click in here and up here I say create folder, and I'm going to call this underscore project. This is a naming convention I believe I got from Jason Story from Infallible Code, which because this has an underscore in front of it, it shows up at the top of my hierarchy here. And I'm going to drag my scenes folder into there. So anything that's specific to this game, to this project, I'm going to put under this folder. And this will help me distinguish it from the other packages that are built in by Unity, and also ones that I import from the Asset Store, and keep them separate from my project. I'm going to create some other folders in here. Notably, I'm going to create a scripts folder. And this is where I will put my C# scripts that are specific to this game. I know I'm eventually going to want some prefabs, so we'll create a prefabs folder. I'm probably going to want materials and I might create some sprites, but I'll leave this here for now. I think this will be good for now. In my scripts folder, I'm going to create an assembly definition, and I'm going to call this 3D Space Shooter. And so all my scripts are now going to be associated with this assembly definition, And what that means is if we were to look at this in the project structure in the editor, in the code editor, you would see that all the scripts that are specific to this game are grouped under a single assembly. And that will help compilation times go faster. So when I make changes in scripts that are only in this project, it won't be recompiling scripts for all these other things. So that's just a thing to make recompilation faster. So the next thing we're going to want to do is we're going to import some assets that we're going to need for the project that are specific to 3D space games. These are all free assets. I've got a little text file here. I'm going to include all these links in the description of the video. So we've got our UnityHub, which you've already downloaded. You might have to actually go to the Unity Asset Store and search for these and then purchase them, and then they will show up under your assets. So under my assets, I've already purchased these even though they're free. But if we look at SpaceSkies, you'll see SpaceSkies free listed here. And this is the link in the asset store. So I will drag that over here. I'm going to copy that link. And you can see it's got some really nice skybox images that will look great in our game. And it's free. So I'm going to edit my text file that has those links and paste that in there and save that. And so I've already purchased this and I've already downloaded it. If you hadn't already downloaded it, this would be a download button. So you'd click that and it will download it. And now I'm going to import it into our project. And this will take a little while. And so after you click import, it lets you select what you specifically want to import into your game. Probably for optimization purposes, you would not want to import demo. I think I'm only going to import the 2K versions of all these images, because I think they're going to look good in our game, and this will help save some space. All right, so I will import those. And if we go down and take a look under assets, you'll see we have SpaceSkies free. Now I'm going to create another folder under assets. And I'm going to call this packages, or asset store packages. And I'm going to drag that into there. And Unity is smart enough to be able to know where to reference that, even though I've moved it into another folder. So now let's go back to the package manager and let's look at our little text file here. I'm going to want one called high-res spaceships creator free sample. So we will say high-res spaceships creator free sample. I've already downloaded it. I will import it. This is a really cool pack because it gives us these modular spaceships where you can mix and match different components. And they have them with cockpits. Well, they all have cockpits, but they have, like, some of them have internal information for the cockpit. So you can put a camera inside the cockpit and get a cockpit view. It's very, very cool. So I'm going to go ahead and import that. This is a very, very nice package. And it's free. So this developer has tons of other really cool spaceship assets that you can purchase from the asset store. And this is basically a free sample. So I'm going to go ahead and drag that into our asset store packages folder. And we're going to go back to the package manager, look at our text file again, and I want to download a free sci-fi fighter. And I thought I was typing in there, and I wasn't. Free sci-fi fighter. I've already downloaded it, so I will import it. And this, I think, will make a cool enemy to shoot at. That imported quickly. And I know, looking at my text file, that I also wanted to import a 3D games effect pack. And it is free. So here it is. I've downloaded it. I will import it. So these have some different particle effects that I think might be cool at different stages of the game. I'm not sure if I'll use them or not, but I'm just going to go ahead and import them. Okay, and it actually overwrote my sample scene with a scene from that pack, which is fine, because I'm not going to use that sample scene anyway. I also know I'm going to want to use Cinemachine, which is a really cool built-in cinematic camera package for Unity. So we'll go ahead and install that. And there's probably some other packages that we're going to want, but we can import them when we get to start using them. I just want to get us up and running as quick as possible in this video. Okay, so let me go back and look at this, and I need to drag the Sci-Fi Fighter into our Asset Store Packages folder. So that's very nice. Creepy Cat also, this is the one that has those 3D game effects. That needs to be dragged in here as well. Now our sample scene has been overwritten. And it's got all this junk in there. If we were to hold down our right mouse button and use the WASD files to fly around, you'll see they've got this little, what they call a showroom here. And if we were to play this scene, it would basically show us within the scene the different effects. But I'm going to go ahead and delete everything from this scene except for the directional light and the main camera. Okay, and so now what do we want to do to actually get, and I'm going to rename this scene, by the way. I'm going to rename this main scene. And so what are we going to want to do to get our project started and off the ground? I think the first thing we're going to want to do is add a really cool skybox background that our ship can fly around in. So I think I want to go ahead and get rid of this scene. And I'm going to create a brand new scene. I am going to call this main. I'm going to open that up. Okay, so we have a new scene. It's called main. It's got a main camera and a directional light. So I want to create a new empty game object, and this is going to be a container for all our background objects. I'm going to call this -- background. And you can see that it's an empty game object. All it has is a transform, and I always like to reset my transform to world, what they call world origin, which is 000. And we're going to create a new camera in here. And I'm going to call this background camera. And over here where you have clear flags, a skybox. That's cool. I like that. The culling mask right now is everything. And so what we're going to want to do is we're going to create a new layer here. And we're going to call this background. All right. And we're going to go back to our main, to our background camera. And we're going to change the culling mask to just be background. See, nothing, background. So it's only going to render what's on the background. All right. And we're going to add a script to this camera, and we're going to call it skybox setter. So we're going to say create C# script skybox setter. We're going to select our background camera, and we're going to drag that script onto it. And we don't want our background camera to have an audio listener, so I'm going to remove that. I think all of these are fine. Okay. And so let's open up our little script here and see what we've got. So you can see we've opened up in the code editor, and if you're using Visual Studio or Visual Studio Code, your view may look a little bit different from mine. I'm using Rider. And by the way, I mentioned that I created that assembly definition for our 3D Space Shooter project, and so you can see that this script is living inside of that assembly. And if you want to go and look, you can see there is another assembly for all of the asset store packages that I created. Okay, so what are we doing in this script here? We're going to want to add a serialized field. So a serialized field is basically a property on this game object that can be accessible through the inspector in the Unity editor. And if you're new to Unity, every game object class that we create in Unity derives from a class called monoBehavior. And this monoBehavior has a number of callbacks that the Unity engine will call. For instance, we have start and update. And you can see from the comment here that start is called before the first frame update. And then update is called once per frame. And so depending on your frame rate, this may be called 60 times a second or 120 times a second. So based on the speed of your processor and how resource intensive your game is in your frame rate, update will be called that many times. So we don't need a start. So we are going to want a serialized field. And by the way, I want to install another package so I can add another attribute called required. That's part of the Odin Inspector package, and that will give us some nice validation in the Unity editor. And also Odin lets you do some really cool code formatting, custom editors and stuff, which will make it a lot easier to configure our game, especially if you have a designer involved. You can hand it off to the designer and make it easier for them to configure things for your game. But our serialized field is going to be a list of materials, and these are going to be our skybox materials that we're going to display in our background. And we'll call this underscore skybox materials. I want this to be camel case with a underscore prefix. That's my naming convention for private variables. And I want to have a local variable, private variable called skybox. And we don't need update, but what we will want is an awake method. And this will set our skybox by using a function called getComponent. So I'm going to have to add a skybox component to this game object. And this function will find a component of that type, in this case type skybox, and it will assign it to this variable. So I can actually add an attribute to our class called require component and do type of skybox. And this will, when we run the game, if I haven't already added a skybox to it, it will actually create one and add it to this game object. But I'm going to go out to the editor because I want to show you how getComponent works. So if we come into our editor now, you should see a property show up here called skybox materials. It's currently an empty list. Now what I'm going to want to do is I'm going to add another component here, and I'm going to call it skybox. So now this game object, this background camera game object, this component has on it my skybox setter script. And so in the script, we're going to look for on that background camera a component of type skybox, and I'm going to assign it there. Now when this component is enabled, Unity is going to call the onEnable callback. And so what we want to do in here is I'm going to create a new function called change skybox, and I'm going to pass in our first skybox. So I'm going to actually pass in an integer, and this will be an index into our collection of skyboxes. So I'm going to let Ryder create the function change skybox for me, and I'll rename this to be skybox. And if our skybox member is not null, and our skybox variable is greater than or equal to 0, and it's less than or equal to skybox materials.count, so we're not going to go out of our index range, then we are going to set the material on our skybox to be our skybox materials indexed by that skybox parameter. So this is going to be an array of sorts. It's a list, but you can treat it like an array, and you can index into it by an integer index. So in onEnable, we're going to pick the first one, and we're just going to assign that material to the material on our skybox component. Okay, so let's go back into the Unity editor, and we're going to want to populate those skybox materials with some materials. So you remember we have in our assets SpaceSkies free, and so here under skybox 1 we've got that one, and then skybox 2 we got that nice green one, and then we got a purple one. So what I'm going to do here is you can just drag these right into this list. So I'm going to go up to skybox 1, and I'm going to take this pink one, and I'm going to drag that right in there. And then I'm going to go down to skybox 2, and I'm going to grab this green one and just drag that right in there. And skybox box 3, I'm going to grab this purple one. And I'm actually going to move these up. I like the purple one better. I want that to be our default, I think. Let's go look at them again. Yeah, let's go with the purple one first. Now, if I click run, boom, there is our skybox being displayed in our background. And you can see it's got this skybox component here, and its current skybox is purple 2K resolution, which was the first one in our list. If we stop playing, you see there's nothing there, right? So we could assign a default. You know, I could drag this guy in here, and that would be our default. But when we run the game, our code in the skybox setter is setting it to our first one. Boom. And now if we were to actually take our background camera and go to its rotation and rotate that camera around, you can see it literally is a 360-degree panoramic skybox. So there we've got our dynamic background, a 3D skybox background with a beautiful space sky skybox for our ship to fly around in. So, like I said, I want to install the Odin package. So we come over here to Package Manager, and My Assets. So you will have to buy this. Odin does have a free trial, and you don't need to do this. I'm just doing this for those that want to see how you can use Odin and the benefits that it provides, but this is totally optional. Do not feel like you have to do this. So Odin Inspector and Serializer. Actually, I'm going to install it as a custom package. You could download it from here, This is actually one that I got from a Humble Bundle deal, and it does not include the validator. So I actually have a version with the validator that I got from a game dev conference. So I'm going to go to Assets, Import Package, Custom Package, and Odin Inspector. And this looks a lot like what it would look like if you're importing from the package manager. And the difference is you will see it's got the Odin validator. So I'll import that. So I don't want to make this an Odin tutorial, but I do want to really quickly show you some of the benefits that Odin gives you. Okay, so if we go back to our background camera, and we click on our skybox setter here to go look at the script, and I look at my serialized field here, I can add a required attribute. And Ryder is smart enough to know that I need to pull this in from the Cyrenex Odin Inspector using namespace. So it will add this using statement here. You can type that manually. In Visual Studio, you would probably, this would be, have an error over it. And if you hovered over it, you could right click and say add using. So it's similar in Visual Studio as it is to Ryder. Ryder just has a little bit better integration. And now, if I was to go back into the Unity editor, and depopulate all of these guys, and go back into the code, okay, so I've added a and I also want to add something called preview field. So if we hover over this, Unity gives us a little pop-up that says it draws a square object field which renders a preview for Unity Engine object types. It also adds support for drag and drop. So dragging an object to another square swaps the values. So anyway, it gives you some samples down there at the bottom of how you can use it. So we'll go back into the Unity editor and watch what it does to this little section here. Now we got a preview of those materials. And you can also click on here to select from all materials either in the project or in the scene. So anyway, I think that's kind of cool. And then the required attributes would yell at me if I did not have that collection on my object, which is nice for validation to help you find errors. Okay, cool. So we've got our background working, our skybox. Let's add a ship that can fly around. So if we go down to our asset store and we expand this high-res spaceships and look under prefabs and examples, you can see there's a number of prefabs we can choose from. I'm just going to grab this example one and drag it in. And you see we get this really cool modular fighter. If we were to expand this out, you can see it's got a cockpit with interior, and the interior has all the different controls and stuff that we can animate. I'll get into that later. It's got separate engines that you can turn on and off. In fact, if we go and look in the back, you can see those engines have a thruster on them, which if we turn them off, Looks kind of cool. That's something we can maybe interactively turn on and off as the ship is flying around if you engage the thrusters. It's got separate missile launchers under each wing, and it's got a couple of blasters, one on either side. So I think this would be a good choice for our player ship. And so what I'm going to do is I'm going to go into prefab and say unpack completely. So this is no longer associated with that prefab. And I'm going to rename this to Escort Fighter. And then I'm going to go back into our prefab folder, and I'm going to drag that in there. So now if I delete this, I can always instantiate an Escort Fighter from our prefab. Now I want to use the main camera to track the ship when it's flying. There's some things we're going to have to do to change it. First of all, if we look at the main camera, the clear flags is set to skybox, which is the same as our background camera. We don't want that. We want to change that to depth only. And then the culling mask, we don't want it to show the background. And we also don't want it to show water. Of course, we don't have any water. But we'll just go ahead and turn that off. So I think that is good. Let's switch over to our game view. And you can see this is what we see in our game view. It's looking at our fighter from behind. And that could be kind of cool for a chase camera, but I actually want to use a Cinemachine virtual camera for that. For now, let's just take the main camera and let's move it forward into the cockpit. And let's move it up. Oh yeah, that looks really cool. I'm not sure if I like that HUD where it is. We may position that later. Let me go up maybe just a tad more. I like that better. So this will be our cockpit view from inside the fighter. Well, one thing I want to do is I want to drag the camera onto the fighter and make it a child of the fighter. So it will move with the fighter when the fighter moves. And let's see, another thing I want to do, I want to move this directional light into here. It doesn't really matter, but it's part of the background and I want it there. Now our background camera is showing up over top of our main camera. If we turn it off, you can see our main camera view. I think all I need to do is set the depth to -1. And I'm just going to go ahead and add this to the background layer. I don't think that matters. So if I hit play, all right. So we can see the skybox background from our cockpit view. The next thing I think we want to do is actually have the ship fly around. So in order to make our ship fly around, we're going to be using physics. Specifically, we're going to be applying force to move the ship forward or backward and torque to do pitch, roll, and yaw on the ship. So in order to do that, we're going to add a component that Unity provides called a rigid body. And a rigid body allows the component to interact with the physics engine. And by default here, it gives it a mass of 1 and has gravity turned on. Now, we don't want gravity turned on when we're in space because it's going to make the ship fall. In fact, I'll demonstrate that. If I hit play, keep an eye on its position on the y-axis, and you can see it's falling. So let's go ahead and stop that. We're going to turn gravity off. And I'm pretty sure that I'm going to want to change the drag and angular drag, because if you think about this, if we apply force and there's no drag, then whatever force we apply, it's just going to keep going as fast as we push it and never slow down and stop. So I'm going to give it some arbitrary values here that I think from experience will work. So a drag of 2 and an angular drag, that's going to be how much we roll, pitch, or yaw. Basically, this will slow down torque over time. I think those are good for our rigid body. Now we're going to need a script. So if we go in our scripts folder, I'm going to create a new folder. I'm going to call this ship controls. And if we open up that folder, I'm going to create a new script, and I'm going to call that ship controller. And let's just go ahead and open that up in our code editor. Now, I do know that I'm going to ultimately, in the future, have a scriptable object that I'm going to use for the ship data. Basically, it's going to be the parameters that control what the thrust force is, the yaw force, pitch force, roll force, all that stuff. But for now, just to get this tutorial moving, just so we can have our ship fly around and demonstrate how that will work, I'm going to go ahead and put them right here in this class. I'm going to use the box group attribute, call this ship movement values. And this will be a serialized field, and it will have a range. So I want these to be anywhere between 1,000 and 10,000. And this is not an Odin attribute. This is just a straight up Unity attribute. And this will give us a sliding bar that we can use to adjust this value up and down in the editor. So this is going to be called thrust force. And I'm going to give it a default value of 7,500. I'm going to copy this attribute. Actually, another way I can do this, instead of copying that attribute, is I can just put a comma here, and I can add pitch force and roll force and yaw force, and give them all default values. Let's see, 7,500. Let's put them on a new line. New line, let's see, pitch force. I think I want that to be about 6,000. And roll force, I think I want that to be about 1,000. And I'll probably end up adjusting these in the editor. And yaw force will do 2,000. Let's go see what that looks like if we go back to the Unity editor. And we have our fighter selected here. And we drag our ship control script onto it. And there you see all these controls are in a box group called ship movement values, and they've all got this little slider, right, that we can use to adjust them up and down. So if I didn't have the box group attribute, I'll just show you what that would look like if we took that away. We'll go back into the editor. So now you can see they look pretty much the same. They're just not all boxed together. So like I said, that Odin attribute is totally optional. It's up to you if you want to have it or not. It really doesn't matter. Let's see. I'm going to have some private variables, member variables, the rigid body, which I will call underscore rigid body. And we want to have some variables for, I'm going to call this thrust amount, pitch amount, roll amount, and yaw amount. And I'm going to add an attribute here. This is another Odin attribute called show an inspector. And you'll see why I'm doing that in a minute. And I'm going to give them all a range from 0 to 1. Actually, from -1 to 1. And I'll give them a default value of 0. All right, let's go back into the editor. And you can see those private members are exposed in the inspector with a slider, so I can control them right here in the inspector. Oops. Let me drag you back on there. All right. Okay, let's go back into our script. And in the awake method, So if we hover over this, Unity IntelliSense will tell us that awake is called when an enabled script instance is being loaded. And so what we're going to do in here is we're going to load our rigid body. So we'll say our rigid body equals get component rigid body. And now we can use that to move our ship around. Now we're going to do our movement in a callback called fixed update. If we look at this in IntelliSense, it says that it's a frame rate independent monobehavior.fixed update message for physics calculation. So essentially, anytime you're manipulating an object through physics, you want to do it in fixed update. And it's frame rate independent. And so we'll be taking advantage of the time.fixed delta time to make sure that we smooth any movements that we make out over time independent of the frame rate. So what we're going to want to do in here is we want to check, and we're going to take advantage of a built-in mathf function called approximately. And we want to say if the pitch amount is not approximately 0, so we are pitching or up or down, then we're going to want to add some torque to our rigid body. And I want you to think about this. So if we're going forward and we want to pitch up or down, we want to add the torque on the horizontal axis, right? So the way you do that is we would take transform.right. So that's our horizontal axis. And we're going to multiply that times our pitch force times our pitch amount. And we're going to adjust it by time.fixed delta time. All right. So we should be able to go into the editor and hit play. Now, if you look at our rotation here, if I adjust our pitch amount, you can see we're rotating up and down on the x-axis. Now, it doesn't look like it except for the light that's changing in the cockpit. And the reason that is our background is not following the movement of our main camera. So we have a background camera that's rendering that star field, our skybox. We're going to have to add a script to it to match the rotation of this camera. So this camera lives on the fighter. And as the fighter moves or rotates, the camera moves or rotates with it. And we're going to want to rotate or move that camera, the background camera, we want to match its rotation to the rotation of this camera. So let's go ahead and do that now. Go back up to our scripts folder. I'm going to create a new script. I'm going to call this match rotation. Open that up in our editor. And we're going to have a serialized field. We'll make this required. Again, this is an Odin attribute, so you don't need to add this. This is, oops. How did I do that? I wish I knew the keystroke I used to do that, because that's useful. All right, require. Autocomplete is not being very nice to me today. Okay, so required. Got that. And this is going to be a transform, and I'm going to call this target. So we don't need to do anything in start. And I actually think I'm going to do all this in late update. So this is another callback that Unity gives us. So we hover over this and let IntelliSense tell us what it is. It says it's called every frame if the behavior is enabled. But this will take place after the other update and fixed update and everything else happens. So what we're going to do is we're going to say that our transform rotation equals the target's transform. Well, the target is a transform dot rotation. And that really should be all we need for this script. Get rid of those unused using statements. Go back out to our Unity editor. Pick our background camera. I'm going to go ahead and collapse all these guys. And I'm going to drag that match rotation on there. Odin gives us this nice big error message here saying that we don't have a target. So for now, we're just going to take our main camera and drag that on there. So let me hit play. Going to go back to our fighter and let's adjust our pitch. And now as we pitch up and down, you can see that the motion is reflected in the background because we're rotating our background camera to match our camera. Cool. So now we'll be able to see our movement actually take effect. So let's go ahead and implement the other axes of movement. So we've got our pitch. Let's do the same thing for roll. See, we're going to do approximately 0, roll amount, and we're going to add torque. Now, what axis do you think we want to use if we're going to roll left and right? I'll give you a second to think about it. The answer is forward. So again, visualize this. If we have a line going through our object from back to front, if we add torque along that axis, we're going to roll to our left or right, which is exactly what we want. So we're going to multiply that by our roll force times our roll amount and adjust that by time.fixed delta time. So that's roll. Do the same thing for yaw. I like saying that, yaw. Can you tell I'm from the South? Okay, transform. Now for yaw, we're going to use the forward axis. Is that right? No, we're going to use the up axis. So imagine we have a line going up and down through our object. If we rotate around that, we're going to rotate counterclockwise and clockwise. So let's use up, multiply that times our yaw amount times our yaw force, adjusted by time.fixed delta time. So I will go back into the editor and I will hit play. So we got pitch, we got roll, and we got yaw. All right, I like it. And we are going to wire these up to some input controls so we can use the keyboard and the mouse to control the movement of our fighter. But for now, let's go ahead and implement thrust. So I'm going to do thrust last after we've done pitch, roll, and yaw. Do the same old approximately, we'll say, we'll compare it to 0 first. Thrust amount. Okay, I like that. So what do you think we're going to add here? We're not going to add torque. The answer is force. We're going to add force. And we're going to apply that on the forward axis of our transform. So we'll say transform.forward. Get my mouse out of the way. And we are going to apply our thrust force times our thrust amount, adjusted by time.fixed delta time. Let's go back into the editor and hit play. Now I'm going to expand our transform. So if I apply thrust, you're going to see our position change. But it doesn't look like we're moving, does it? Now there's a very good reason for that. We are matching our background's rotation to our ship's rotation, but that's not going to show us movement forward. Okay, it's only gonna show us if we're pitching, rolling, or yawing. It's not gonna show us if we're actually moving. So what we need to add some things to the scene to fly around. And until we add things like enemy ships and asteroids and junk like that, there's really nothing in the scene relative to show that we're moving. But what we can do is we can add a particle system to our ship that will spew out, I guess, space dust, for lack of a better word, around the ship that we can fly past to give us the visual indication that we're actually flying. So let's take a look at what we can do here. We can add a component to our ship. I could create a whole separate game object for this and call it something like space dust. But for now, let's just go ahead and add it to our ship. It's going to be a particle system. And you can see it's already spewing some stuff out around us. If you look at it in the scene view, you can see it there. Now, the reason they're pink like that is because there's no material associated with what we're spewing out there. But we're going to want to adjust several parameters for this particle system. First of all, we want the duration of the particles to last a while. We definitely want it to loop. Let's have our start lifetime be 4. I think all that looks good. Start size, let's make them a little bit bigger. I don't think we want to do anything with start rotation. Color should be fine. We want it to spew in world space, not local space. Let's keep going. Let's see. Max particles, I think I want to have about 10,000 of them. We definitely want it to play on a wake. Simulation speed 1 should be fine. All that should be cool. Let's go look at some of the other settings. So we'll expand emission. Let's take a look at that. I think we want to have more of them than 10. All that looks fine. The shape, I don't think we want a cone. Let's try a sphere. And for our radius, now we're starting to look like something interesting. Make our thickness 0.5. Arc 360 is good. Random is good. Okay, I think all of that is cool. What else we want? For the color over lifetime, I think what I actually want to do is I want to change the alpha to be something like this. So I'm going to add a point. And on this one, I'm going to turn it all the way down. I'm going to add a point. And on this one, I'm going to turn it all the way down. So now we have a fade in and fade out kind of thing going on. Okay, that looks cool. I think the only other thing I want to do is under the renderer, we want to assign a material to this guy. I believe that there are materials included in some of the free packs that I imported that we can use. Let's try that one. Okay, do I need to change anything else here? I think all this stuff looks good. All right, we switch to our game view. Doesn't look like anything's happening, but let's pick our fighter here and hit play. And close that down. Let's thrust. Oh yeah, now we got some Starfield stuff, some space dust flying by. Is it starting to look like we're flying through space? I like it. Okay, it's time to get the input wired up for this. And I'm going to abstract this out in such a way that I can swap out the input controller for various ships. So you can have a human-controlled ship, and it might be a different type of input depending on whether you're on a mobile device or a web page, or a desktop app. And I also want to have computer-controlled, bot AI controllers for enemy ships and even allied ships. So to do this, I'm going to first create an interface. And I'm going to call this I movement controls. Open that up in our editor. And this is going to be not a mono behavior, and it's not going to be a class. It's going to be an interface. And I'm going to go ahead and get rid of all those using statements. And we won't need these callbacks. And the interface is going to be really simple. It's going to have yaw amount. Is that what I want? Yeah, I think I want to name it what I called it in the other class. So I'm going to call this yaw amount. Pitch amount. Roll amount. Thrust amount. And since this is just movement controls, I'm not going to put the fire. I want to have inputs for when you fire primary or secondary weapon, but I don't want that to be part of the movement. I might have another interface that combines this interface and the fire controls interface. But for now, I'm going to keep this just movement. Okay, let's go back into the Unity editor. And I'm going to want to add another class. And this is going to be an abstract base class from which I can derive other input control classes. So I'm going to call this movement controls base. If I open that up, this will implement the I movement controls interface. Okay. Now, the only thing I want to do differently here is I want this to be abstract. And what abstract means is that you cannot instantiate an instance of this. You have to have a derived class that derives from this base class, and you can instantiate that. So all these functions are going to be abstract as well. And actually, these aren't functions, they're properties. Okay, so go back into the editor. And let's go ahead and create a class that derives from that. And I'm going to call this desktop movement controls. And this will derive from movement controls base. And we'll go ahead and get rid of all that. And I think I might want this to be serializable. I don't know if this is necessary, but I think since I want this to show up in the inspector and be editable, I'm just going to put that on there just to make sure it can be serialized. And we'll create a serialized field. So we're going to use the mouse to control our yaw and pitch. So when you move the mouse horizontally, it will yaw left or right. And if you move it vertically, it will pitch up and down. But I want to have a dead zone. So like if this is the center of your screen, if the mouse is anywhere in here in this dead zone, I don't want it to apply any pitch or yaw. Only if you move outside of that dead zone. So I'm going to create a floating point variable, and I'm going to call it dead zone radius. And I'm going to give it a default value. I really don't know what I want this to be, but we'll just default it to that for now. And we want a couple of other private properties. Since we're going to use the mouse, and the mouse is going to determine whether we pitch or yaw based on its position relative to the center of the screen, I'm actually going to use a vector 2, because this will give me an XY coordinate. And I'm just going to call this screen center. And this is going to return a new vector 2 that's composed of screen dot, I think width would come first. Width times 0.5, screen height times 0.5. Maybe if I remove float. Okay, that was a stupid mistake of mine. I started out as a float and then switched to a vector 2, and I didn't delete the float keyword. Okay, so screen center will give us the center point of our screen in the X and Y direction. So screen center.x, screen center.y will be in the center of the screen. All right, now we want to implement all of our missing members. So what do we want to do on all these? So for the yaw amount, we're going to get our mouse position, which is going to be a vector 3. And our yaw will be our mouse position dot x. So yaw is we're going to rotate left or right on the horizontal plane. We're going to subtract the screen center dot x, and then we're going to divide that whole result by the screen center dot x. And then if that is outside of our dead zone radius, then we want to use that value. So what we're going to do is we're going to return, and we're going to use another mathf helper function called ABS. This is going to give us the absolute value, because this can be negative or positive. All we care about is this the absolute value of yaw greater than our dead zone radius. If it is, we want to return that. Otherwise, we're going to return 0. So this is what's called a ternary statement. So there's a little question mark here. It says evaluate this condition, and if it's true, if it's true, take this value, and if it's false, take that value. So this is shorthand for saying if math ABS yaw is greater than dead zone radius, then use yaw, else use 0. So that's just a way to kind of simplify an if then else into a single line. Let's do the same thing for pitch. So our pitch amount is going to do the same thing, except we're going to take the Y position. So again, we're going to take vector 3, mouse position. Our pitch value will be mouse position dot y minus screen center dot y. Divide all that by screen center dot y. Okay. And then we're going to return mathf.abs pitch is greater than dead zone radius pitch or 0. So roll is not going to use the mouse. For roll, we're going to use the keyboard. And I'm probably going to add something where I can define what keys, let the player define what keys he wants to use for pitch and roll and all that. But for now, all I'm going to do is say if input.getKey keycode .q. So on your keyboard, I'll use Q for roll left and E for roll right. Actually, I can use a ternary statement here too. Return. Actually, I can't because this is going to have another condition. You'll see, I'll use a ternary statement in the second part of this. All right, so if that, return 1. So otherwise, I'm going to return -1 or 0. All right, so if we press Q, we're going to rotate 1 in the around the forward axis. Otherwise, we're going to roll -1 along the forward axis. Finally, thrust. You know, I can actually make this an expression body method because this is going to be really simple. I'm just going to return input.getAxis. So by default, axis is going to handle the keys I want for forward and back, which are W, S, A, and D. So W and S will be the vertical axis, and that's what I want to use for forward. And that will already be a normalized value of -1 to 1. Okay, so I still don't understand why it's telling me that, but I'm not going to worry about it. Let me go back into the editor. And I know this is going to seem kind of convoluted and confusing, but it's going to make things a lot simpler when I start adding enemy ships and allied ships and different types of input controls and that sort of thing. So let's create a new script here. I'm going to call this ship movement input. And this will be a mono behavior. And I'm going to add a serialized field. You know what? I think I need another class before I can do this. I want to have a ship input manager. Let me go ahead and create that. It's a lot of moving pieces, I know, but it's going to make things so much simpler down the road. Okay, so our ship input manager, I'm going to create an enumeration called input type. And I'm going to have human desktop, human mobile, and bot. Okay. I don't think I need start or update. But I want to add a static method to this guy. I movement controls get input controls input type. So basically, when I pass in one of these input types, this guy is going to instantiate a new input controller for us and return it. And this is why I'm using the latest version of Unity, because this is a new C# feature that's introduced in 2022. It's actually C# 8, which Unity didn't start using until 2022. But I'm going to return input type switch. So this is just a new way to do a switch statement. And if it's a human desktop, then I'm going to return a desktop mobile control. And for now, since I don't have a human mobile, I'm just going to return null. Same thing for bot. And then if you want to have a default value, you just put an underscore. So what I'm doing here is I'm throwing an exception if I pass in a value that's not one of our enumerations. All right, so that gets us close to being able to implement our input. Okay, so in ship movement input, have a serialized field. It's going to take a ship input manager dot input type. And I'll call that input type. And let's give it a default value of human desktop. And let's see. Have a public variable of eye movement controls. And I'm going to give this a public getter and a private setter. So I can only set it from within this class, but I can get it from anywhere. And in start, we're going to get it. We're going to set it. Say movement controls equals ship input manager, get input controls, input type. So whatever the input type for the object that this script is sitting on, it's going to go get me the appropriate controls for it. And I don't need update. Let me get rid of this comment too. But I do want an onDestroy callback. In an onDestroy, I'm just going to set movement controls to be null. Garbage collector will clean it up. Okay, so the ship input manager, I think that all looks good. We got our ship movement input. We got our desktop movement controls. That all looks good. All right, so let's go to the ship controller. So what do we got here? We're going to need to add that movement input. So let's add a serialized field. And we want that to be required. Now this is an optional Odin parameter, so don't add this if you don't have Odin. And I'm going to call this ship movement input, movement input. And I'm going to add another optional Odin attribute called inline editor. And I want to use the boxed format. And I'm going to add another variable down here, actually a property. Movement controls, control input, expression body method, returning movement input dot movement controls. And we'll use those in our update method to adjust these pitch amount, roll amount, yaw amount, and thrust amount to control our ship. So if we go down here to update, I'm just going to say thrust amount equals control input dot thrust amount. Roll equals control input dot roll amount. Yaw amount control input dot yaw amount and pitch amount. So we're getting these values in update, and then we're using them in fixed update. This is a typical pattern to control objects in a game. Let's go back out to our editor. And let's look at what we need to do to get all this to work. Let's give me a syntax error in ship input manager on line 20. Okay, that's why I had an error over there. All right. Wonder if any of you all caught that watching the video. So you see here, it's yelling at me because I have not given it any input. You know, I think we need to create a new game object for our movement input. I could add the script directly to this, but I think I want to create a game object for it. So I'm going to say create empty ship movement input. And I'm going to drag that script onto there. I'm going to come back here and drag that into here. And now, because I added that inline editor attribute, I could actually drop down here and change what type of input it is directly from this script. Okay, I'm going to save that and hit play. Something is not behaving quite right. I am pitching uncontrollably. And I see I have some errors in the console. So this is all coming from our input controls. It has to be related to this. Which is really confusing me. Let's just bypass that. Do you all see it? What I was doing in here was an equal instead of a minus. Did you all catch that while you were watching? Let's go back into the editor. Even I make silly mistakes like this sometimes. I'm humble enough to admit it. All right, so I'm pitching up, pitching down, yawing left. Oh, I got to increase that yaw rate. That's a little slow. What is it set to? It's only set to 2,000. I think we can crank that up. And then roll and thrust. I think the pitch amount's too high. It just seems to be pitching awful fast. Why did I set that to 6,000? That just seems crazy. All right, so let me come over here. By the way, it's giving me these errors because I went outside of my window here. I'm going to do another thing before I end this little segment. I'm going to hide the mouse cursor, and I'm going to add a way to quit the game by pressing escape. Let's put this down to about 2,000. Just edit it here. 2,000. Actually, let's make it 3,000. Oops. And we'll see if roll looks good. All right, so there's our pitch. I might also give the player the option to invert whether moving the mouse up pitches up or pitches down, because if I was actually moving the joystick with my mouse, it would be the opposite. I think I do want to invert it because I'm confusing myself by I'm expecting the pitch. the other direction when I move the mouse. Yeah. But that's looking pretty good. We're flying around. Let's go into our desktop movement controls, and when we're doing pitch, let's try that. Yeah, that makes a lot more intuitive sense to me. But I still think, I don't know, does that yaw amount seem a little slow to y'all? I think I'll leave it like that for now. But I'm liking that. I'm flying around. Okay, real quick now, how do I hide the cursor? I think I'm going to want to add a game manager to handle that. Yeah, let's go up here in our scripts. I'm going to create a folder. I'm going to call it managers. Oops, caps lock was on. Managers. And I'm going to create a script called game manager. Let's create a new empty game object. Call it managers. Oops. Reset the world origin. You know, there's a setting I can change so this would happen automatically. I should do that. And I'm going to create another empty game object in here, and I'm going to call it game manager. And I'm going to create a script to go on the managers group. And I'm going to add a static variable. And this is going to be a private variable called instance. And I'm going to implement what's called a singleton pattern. I want to make sure there's only ever one of these. So in the awake method, I'm going to say if instance is not equal to null and instance is not equal to this, then I want to destroy this .game object. Else, I'll assign this to instance, and I'm going to call don't destroy on load on the game object. So that way this thing will always exist in the scene, never be destroyed. No, there will only ever be one of these. And everything that lives underneath of managers will also have inherit don't destroy on load and live forever until we quit the game. So I also want to move this up to the top of my hierarchy. And we're going to drag our game manager script onto there and open that up. So in start, I want to lock the cursor. And I want it to be confined to the game window. So if you look at that, cursor, confine cursor to game window. And the other thing I want to do is hide the cursor. So we don't see the cursor floating around the game window. And then in update, I'm going to say if should quit game quit game. And I'm going to create a property here called should quit game. And I'm just going to check to see just check for get key up, key code dot escape. So if we press and release the escape key, should quit game will be true. And then here, we're going to check to see if we're in the Unity editor. So I'm adding what's called a preprocessor directive. All right, so if Unity editor, else, end if, and then inside of this code block, okay. So we're in the Unity editor. We will call Unity editor application is playing equals false. Otherwise, so if this was I actually should check to see if it's a desktop application, because WebGL, this won't work on a WebGL app. But for now, I'm just going to leave this as it is. I'm going to call application.quit. And I'm going to put a to-do handle WebGL. Get rid of those unused using statements. Go back into our editor. We should, as soon as I click play, see a don't destroy unload group form over here. But we did not. And I still see my cursor. And it's not confined to the window. And escape did quit the game, though. Need to drag my manager script onto there. Not sure why this did not seem to work. Let me try running that again. So we have don't destroy and load, and game managers and game manager live under there. But okay, I see what was wrong. I wasn't focused on the game window. So once I focus on the game window, my cursor is locked. And it's confined to the game window. All right, cool. And if I hit escape, it stops playing. All right, so I think the next thing I'm going to do is I'm going to animate these controls in the cockpit so you can see how they move in relation to the input controls. But I think I'm going to save that for the next video in the series. So that wraps it up for part 1 in this series. If you found it useful, and I hope you did, please do me a favor and click that like and subscribe button. It really does help me out to grow my channel, and I want to get this content in front of as many people as possible to help them on their game development journey. So join me in part 2 of this series as we continue developing out this 3D space shooter. And once again, thanks so much for watching, and have a great day.